Sometimes it's the imperfect jump which provides the big thrill.
Even a very small increase in that surface area could equate to, say, a meter or two additional distance. The Olympics, a meter or two can really make the difference between whether you get on the medal podium or whether you don't. My name is Chris Roy, professor in the aerospace-and-ocean-engineering department. My specialty is computational fluid dynamics, aerodynamics, and also reliability of computer simulation. The best thing to do to start with is to kind of differentiate between fluid dynamics and aerodynamics. So fluid dynamics, we're talking about a fluid, which is really any gas or liquid. Aerodynamics is focused on gas flows and specifically on flows in air. Hydrodynamics, on the other hand, would be focused on liquid flows and specifically on water flows. So when we talk about computational fluid dynamics, we're dealing with fluid dynamics either in liquids or gases, but we're running things on the computer as opposed to, say, in a wind tunnel or in free flight. There are many, many sports that are very strongly affected by fluid dynamics. Auto racing, boat racing, all of your kind of summer Olympic sports, swimming, cycling, triathlon, critical there. As a former college swimmer and current triathlete, aerodynamics and also hydrodynamics are extremely important in triathlon. Aerodynamics is very important on the bike, basically how fast you can go. So it's how much power you can put into the pedals, but it's also how aerodynamic you can get both your bike, all your bike equipment, and also your body position. On the swim side of things is drafting on the swim. And so if you're able to draft behind another swimmer, maybe a faster swimmer, then you can actually go faster than you can on your own with the same effort. Or if it's a swimmer that's about the same speed, you can actually lower your effort and kind of save that effort for later on the bike and the run and swim that same speed. In terms of things like maybe Winter Olympic sports, ski jumping is probably number one. The key there is you want to try to maximize the amount of lift you're producing while minimizing the drag. And so in aerodynamics, we refer to this as the lift to drag ratio. So if you can maximize your lift to drag ratio, that will give you the longest distance that you can go. In terms of lift, there's basically three ways that you can improve your lift. You can change kind of the shape of your body, so we refer to this as camber. You can change the angle relative to the oncoming wind, and then you can increase your surface area. There was a recent scandal on the Norwegian team where they were sewing a little bit of extra material into the ski jumper suits. The idea there is that you can get a little bit more lift if you can increase the surface area. Maybe even a very modest increase in that surface area can have a pretty big impact in terms of the distance that you can go on the ski jump. Back in 2008 and 2009, there were suits. They were referred to as super suits, but basically they were swimsuits that went kind of from ankle to wrist. They had buoyancy because of the materials they were using. So this is a case where a whole bunch of world records were broken before these suits were banned. Basically what they said is, hey, you can't use these polymer suits, you've got to use textile suits. Much restricted in terms of how large they can be, but they're referred to now as tech suits. They're still very important in terms of aerodynamic shaping and kind of compressing the body in a way to make it more hydrodynamic in this case.